Good evening and welcome to the session number 20 from the playlist of moving charges and magnetism. The topic is the magnetic field due to a current carrying conductor. Now this session is based on the session number 18 in which we have derived the value of magnetic field at a point inside a cylindrical current carrying conductor, assuming that the current was uniform throughout its cross section. So based on that session, I have framed one question for this session, and in this session there are 4 alternatives and we have to find the correct one. So here the question is: a long cylindrical conductor carries a uniform current throughout its cross section. The magnetic field is, first option is maximum at the axis of the conductor, second option is 0 at the axis of the conductor, third option is it is maximum at the surface of the conductor, and the fourth option is it is same at all the points in the cross section of the conductor. So in the session number 18 we have derived the equation for the magnetic field at a point inside the cylindrical current carrying conductor, assuming that the current was uniform throughout its cross section, and the formula was mu naught I small r divided by 2 pi capital R square. So here capital R is the radius of the cylindrical conductor, small r is the radial distance of a point inside the conductor from the axis of it, and so by using this formula we will be able to find the correct options. So at the axis of the conductor, the value of this small r is the radial distance of any point inside the conductor from the axis of it. So in the first option it is written that it is maximum at the axis of the conductor. So at the axis of the conductor, this r will be equal to, small r will be equal to 0. So B will be the value of the magnetic field at the axis of the conductor will be equal to 0. Now second option is it is 0 at the axis of the conductor. Definitely, since r is equal to 0, so the magnetic field will be 0 at the axis of the conductor. So this second option, that is B, is correct. Third, it is maximum at the surface of the conductor. Now at this surface, now here from this formula, B is directly proportional to small r, where small r is what? It is the radial distance of any point from the axis of the cylindrical conductor. Now on the surface of the conductor, this small r will be equal to capital R. So from this formula, since B is directly proportional to this small r, so on the surface of the conductor, the value of B will be equal to mu naught I. This small r will be replaced by capital R, so I will be getting the value as mu naught I divided by 2 pi r. And from this formula we can see that the value of the magnetic field at the surface of the conductor will be maximum, because B is directly proportional to small r, and on the surface small r will be equal to capital R. So this option, that is C option, is also correct. Now the fourth option, same at all the points in the cross section of the conductor. So this is not correct, because B is directly proportional to small r. When small r increases, B will increase, and when the value of small r is decreasing, then the magnetic field will decrease. So this option D is not correct. So here we have got 2 options which are correct, that is option B and option C. So in the next session, that is in the session number 21, we will discuss a different type of a question from the same topic, that is the magnetic field due to a current carrying conductor. So till then, have a nice day. Bye.